Dear students, today we will discuss transportation problem. In transportation problem, initial basic feasible solution can be calculated using three different methods: northwest corner method, least cost method, and Vogel's approximation method. So out of these three methods, we will discuss northwest corner method in detail in today's presentation. So before start discussing about northwest corner method, we should know what is main objective of transportation model. The main objective of transportation model is to schedule transportation by keeping in mind that the total cost of transportation should be minimum. To minimize transportation cost, how you have to distribute the supply so that all demands will be fulfilled and all supply will be consumed. For that purpose, you have to properly distribute the items to the different, we can say, distributors, so that the demand of distributors get fulfilled and all supply will be finished with minimum transportation cost. Before solving examples, we should know some basic terminologies which is needed to be remembered in solving transportation problem. The first is that feasible solution means any solution which satisfies the constraint, that solution is called as feasible solution. That solution is non-negative value of items which satisfies the constraint of supply and demand. That solution is called as feasible solution. Second is optimum solution. Optimum solution is solution from the set of feasible solution, the solution which minimizes, because transportation problem is used to identify minimum cost, which minimizes the total transportation cost. That solution is called as optimal solution. Then transportation problem, there are two types of transportation problem, that is balanced problem and unbalanced problem. So what is balanced problem? In transportation, we have to deal with only two quantities or two items or two things only, that is supply and demand, source or destination. So if the quantity needed, that is called as demand, is equal to available quantity, that is supply, then problem is called as balanced problem. If demand is equal to supply, then problem is called as balanced problem. And if demand and supply are not equal, then we can say the problem is imbalanced problem. Then second, last one is the degeneracy of feasible solution. Degeneracy means what? If number of demand stations and number of supply stations, we treat number of demand stations are nothing but m, number of supply stations are nothing but n. If you do the addition of m plus n minus 1, then that count should be allocations of your items to the particular cells. If that is happen, then you can say degeneracy is happen. The degeneracy is achieved. If the allocations, the number of allocations is not equal to m plus n minus 1, then we can say the degeneracy is not occurred. We'll see with this example how to check that. So before solving, we should know the balanced and unbalanced problem is what. So in this case, S1, S2, S3 are nothing but sources which have capacity to produce this much items, which means having capacity to supply this much items. D1, D3, D4, these are nothing but distributors, we can say, which are having demands of this much quantity. So how to check the problem is balanced or unbalanced? We have to do the addition of supply, we have to do the addition of demand. In this case, the demand is more than the supply. The value of demand is 500 and the value of supply is 450. So supply is less than demand or demand is greater than supply. So to make this problem balanced, we have to add a dummy supply with cost 0. Here I have added one supply S4 whose cost is 0. Whose cost is 0 means what? This 19 is the cost of transporting a single item from source S1 to destination D1. Likewise, we have added S4 as a source which is having 0 transportation cost but having capacity to produce 50 items. Now the problem is balanced problem. Likewise, in this case, the demand and supply, if you compare, the demand is less than supply. So to make the problem balanced problem, we have to add one dummy demand which transportation cost is 0 but having demand of 50 units. So the problem is made balanced. So before solving transportation problem, you have to check first the given problem is balanced or unbalanced. If the problem is unbalanced problem, then you have to convert that unbalanced problem into balanced problem by adding either dummy row or dummy column with the transportation cost value 0 and supply or demand value, which is you have to add to make the problem balance. Basically, there are three types of methods which are used to calculate initial basic feasible solution. The first one is the northwest corner method, least cost method, and Hogel's approximation method. Out of this, today we are going to discuss northwest corner method to find out initial basic feasible solution. So we'll see what is the procedure to solve northwest corner method. So first step is you have to select upper left cell of transportation matrix. And what is transportation matrix? Transportation matrix is nothing but only the cost matrix. We are not taking into consideration the demand or supply column or the names of D1, D2 or S1, S2. Only the transportation cost. That transportation costs are called as transportation matrix. From the transportation matrix, you have to select upper left, that is northwest corner. Northwest corner you have to select, and you have to check supply and demand values. So out of that supply and demand values, which is minimum value that you have to assign for that upper left corner cell. If the value of supply is minimum, then you have to assign all values of S1 to that particular cell, and you have to subtract that S1 value from S1 means that source and demand values or supply and demand values. Then if demand is more, then we have to move vertically down. On the other hand, if the demand is minimum as compared to supply, then you have to allocate all demand value to that particular cell and subtract that value from demand and supply, and you have to move horizontally in next cell. In third case, if demand and supply both are the same, if value of demand and value of supply is same, then you have to allocate either demand or supply because both are having the same values to that particular cost or particular cell, and you have to move diagonally. If demand and supply are same, then you have to move diagonally. Means what? If you are selecting the cell X11, then you have to move X22. X22 will be the diagonal cell. Getting? So in this fashion, you have to allocate all cells till you reach to the bottom right corner. We'll see one simple example to get understood the process. So here one example is given. You have to solve the transportation problem to find initial basic feasible solution using northwest corner method. So here these are S1, S2, S3 are the suppliers. These are the sources which are having capacity to supply this number of atoms. Likewise, D1, D2, D3, D4, these are the distributors which are having demands of this much atoms. So this part is called as my transportation matrix, or this part is called as my cost matrix. So this 19 is nothing but a cost occur to transfer a unit atom from source S1 to destination D1. For that, this much cost will be occur. Likewise, this what is 20 says, from this 20 we come to know that for source S3, if you want to transfer a single atom to distributor D4, per atom you have to pay 20. That may be rupees, that may be paisa, that may be 100 rupees. So this is the cost of transport. This is the cost of transferring single unit from source to destination. We will see the solution. So what is solution? Here first you have to take into consideration what is total demand and what is total supply. Here demand is equal to 34 units and supply is equal to 34 units. Means just you have to do the addition of supply and you have to do the addition of demands. And we know that the demand and supply is equal to 34. Hence the given problem is balanced transportation problem. Once you identify the problem is balanced transportation problem, the next thing is that you have to start allocation from your upper left corner. This cell is called as upper left cell of your transport matrix or cost matrix. This cell is a upper left corner. So from this upper left corner, you have to check the supply and demand values. So out of these demand and supply values, which is minimum value? 5 is the minimum value. So we have to assign the 5 capacity to this particular cell. When you assign 5 here, you have to subtract 5 from demand as well as supply. So if you subtract 5 from 5, we get 0. When you subtract 5 from 7, you get 2. So here demand is more, here supply is more as compared to demand. So we have to move horizontally. So in next case, we are here. Now what you have to do, we have to compare the supply and demand. So in this case, supply is 2, demand is 8. So minimum value is 2. So we have to assign 2 here. Then subtract this 2 value from supply as well as demand. So when you subtract 2 from 2, we get 0. 2 from 8, we get 6. Now we have to compare the demand and supply. Supply is 0 now, demand is 6. So demand is more. So we have to move vertically down. So in third case, we are in this cell. So we have to compare the values of demand. The value of demand is 6 and when the value of supply is 9. So which is minimum? 6 is minimum. So we have to assign 6 value here. Then you have to subtract this value from demand and supply. So when you subtract 6 from 6, we get 0. 6 from 9, we get 3. So then we compare the value of supply and demand, which is maximum, demand is maximum, sorry, supply is maximum, then you have to move horizontally. If supply is more, we have to move horizontally. If demand is more, you have to move vertically. So in this case, supply is more, so we have to move horizontally. So when we are in this cell, now you have to compare the supply value and demand value. So supply value is 3, demand value is 7, minimum is 3, so we have to assign 3 here. So subtract 3 from 3, we get 0. Subtract 3 from 7, we get 4. The demand is more, so we have to move vertically down. So when we are in this cell, we have to compare the value of demand, that is 4, with value of supply, 18. Minimum is 4, so we have to allocate 4 here. Then subtract 4 from demand and supply. So 4 minus 4 is 0. 4 minus 80 minus 4 is 14. So here value of supply is more, so we have to move horizontally, right? So in this case, here the demand is 14, supply is 14. You have to allocate any one value here, that is either demand or supply, both are same. You can write 14 here and subtract 14 from demand as well as supply. You will get 0, 0. So how to check the problem is finished or correct? If when you reach at bottom right corner, if the value of supply and value of demand is 0, then we can say we have solved the problem properly. Then how to calculate total cost? To calculate total cost, first you have to check whether degeneracy is achieved or not. What is degeneracy? We have to count how many demands are there. 1, 2, 3, 4. 4 demands or 4 distributors are there. S1, S2, S3. These are 3 suppliers. So 3 plus 4, 7. 7 minus 1. 7 minus 1 is nothing but 6. So we have to check how many allocations we have done. 1, 2, 3, 4, 5, 6. Where here m plus n minus 1 is equal to 6, which is equal to number of allocations. Number of allocations is equal to m plus n minus 1. Hence, degeneracy is achieved for initial basic feasible solution. How to check the degeneracy is achieved? If m plus n minus 1, m is nothing but number of distributors, n is nothing but number of suppliers. If you add m plus n and subtract minus 1, if that number of allocations we have made, then we can say degeneracy is achieved. And the optimal transportation cost can be calculated by doing multiplication of allocation units and cost. 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20. If you do the addition of all those multiplications, you get the optimum transportation cost or minimum transportation cost required to transfer all the supplied quantity to the all different distributors. You have to pay rupees 1050. So here we have completed this first example. If you have any doubts regarding how to calculate initial basic feasible solution using northwest corner method, you can call me. For that, my mobile number is 98500 98225. My name is Dr.B.J.Mohite. Thank you all.